Estou aqui, fala Creeper Gamer e estamos aqui para mais um vídeo no canal. Eu estou mesmo a fazer um vídeo com os óculos virtuais. Não sei se vocês estão a conseguir ouvir a minha voz no caso deste daqui.
And to think, each one of those 100 billion stars has its own planets, its own strange worlds. Imagine what it would be like to visit some of those exoplanets beyond our own little solar system. Well, today, you don't have to imagine, because I'm going to take you on a tour of 6 real exoplanets. What you're about to see is based on the latest scientific research, and as we travel across the cosmos, we'll hear astrophysicists from the University of Exeter tell us about their search for planets beyond our solar system. So, if you want to experience what it might be like to stand on another planet, I highly recommend strapping on a VR headset and a pair of headphones to feel truly immersed. Feel free to pause the video here whilst you get what you need to start your journey. Okay, are you ready?
Não.
Let's go.
Não estou pronto. Adeus. Não. Uau! Uau!
I'm Elizabeth. I'm studying observations of debris disks and trying to find debris disks in giant planets. So the planets will form over maybe 4 or 5 million years as the star forms. So the star forms out of a massive cloud of dust and gas, and that collapses down, and the centre of that will fall inwards and become a star. But then there'll be a whole cloud of dust and gas and stuff left, and that kind of collapses down into a disk that's just made out of kind of the leftovers from the star formation. And then that disk, the individual bits of dust will collide to each other, and they can sometimes stick together. We don't really understand that yet. Sometimes they stick and sometimes they bounce off, and no one really knows how they can stick together enough to start to form a planet. But then as soon as you have a big core, we call it a planetesimal, so it's maybe 10 kilometers across. That's big enough that its gravity starts to scoop up all of the rest of the nearby stuff, and then it kind of slowly picks up more and more bits of dust and gas, and they fall down onto the surface, and eventually it grows into something like Jupiter, or even bigger than Jupiter.
Não. Não. Nossa, um sol. Okay, come.
I'm Professor David Singh, and I study transiting exoplanets and their atmospheres. Well, hot Jupiters are gas giant exoplanets, but they orbit much, much closer to its star than Jupiter does to our own sun. In fact, they orbit so close that the day side of the planets are heated up to thousands of degrees Kelvin. And because they're so hot, a lot of the atmosphere around the planet actually evaporates off. Sort of like when a comet gets too close to the sun, you see a lot of evaporation. If the comet happened, a similar process happens for these planets. They orbit so close, a lot of the atmosphere is being blown off. Because these planets are so close, we expect them to be tidally locked, which means the same part of the planet will always face the sun. And what that does is set up a very large day-night contrast in temperature. It's very hot on the day side, it will be quite a bit colder on the night side. And this will in turn create large-scale weather patterns around the planet. If this particular planet was any closer, it could actually break apart.
Sério?
But what might it look like inside the atmosphere of one of these extreme gas giant exoplanets? Let's find out.
Agora é o quê? O que é isso?
My name is Stefan Lines. I'm an exonephologist, which is someone who studies clouds on extrasolar planets.
Aqui.
So what we're looking at is planet Osiris, otherwise known
Olha
as
ali.
HD 20945
Parece um mini tornado.
and these are extremely strong winds. Going from the west to the east of the planet, from the day to the night side, the wind speeds are reaching about 5 kilometers per second, which is about 10 times faster than Concorde. Osiris has a temperature of around 1,000 degrees centigrade. With these temperature ranges, we're